welcome back. It's Adam, the Science Tutor, and today we're going to be going over polar versus non-polar molecules. This is a basic chemistry idea and something that a lot of kids struggle with early on. And it's just it's an easy subject, but a lot of times I feel like professors make it harder than what it is. And yeah, today we're just going to be going over it and seeing what is polar, what is non-polar, what does it mean, and what's it mean? Where is the direction going? What is it? Pretty much, what is the definition of polar and non-polar? So up here I'm giving you guys two examples. So a polar molecule, water. Water is a polar molecule. A non-polar molecule is CO2. So something that we drink, something that we breathe out. So essential things in life, really. So this is the construct of a water molecule. You see we have two hydrogens, and I'm going to ask you guys in a bit what are these the bonds between them. And then over here on the non-polar molecule, carbon dioxide, we have two double bonds between the oxygens and carbons. So I'm going to come over here, I'm going to talk about polar molecules first. So what does it mean to be polar? So polar is any time when there's, well, let me talk about this first. So what bond is right here? So we're going to talk about the bond between the oxygen and hydrogen. So is it a hydrogen bond? Is it an ionic bond? Is it a covalent bond? What bond is between the oxygen and hydrogen? Well, it is a covalent bond. And it is so they share, and a covalent bond is when the electrons are shared between the oxygen and hydrogen. So hydrogen has one electron that is being shared going into the bond. Oxygen, of course, has 6, and so it's also giving off an electron to form the covalent bond. So it's covalent and covalent. And so with these bonds, since it is polar, it's an unequal sharing of the electrons. Oxygen is more electronegative than hydrogen, and electronegative means that it hogs electrons. It wants electrons. It's pulling the electrons up and away towards it. So we're going to go here towards the oxygen, which creates unequal, and then we have a slight pull and a slight pull towards the hydrogens. So this creates, I'm going red, this creates a partial negative and a partial positive. So whenever you see this little sign, it's a partial sign. So it's a partial positive on the hydrogen, partial negative on the oxygen. Whenever you see any partials, that's when you know the molecule is going to be polar. Because non-polar, I'll get to it in a sec, but it's an completely equal sharing. All the electrons are distributed equally. So over here, back to here, we have a covalent bond between oxygen and hydrogen. I'm gonna go ahead and show you guys what a hydrogen bond looks like in a bit. But this is a water molecule, and you're gonna have another water molecule that'll form to form the hydrogen bonds. But essentially, a polar molecule has a partial negative and partial positive due to the electronegativity of the oxygen atom that is pulling more electrons towards it. So it's a greater pull towards the oxygen than what the hydrogens are able to receive. Because of this partial negative and partial positive, it makes a water molecule very resourceful, and it gives water properties that really not many other molecules are able to have. So let's go ahead and draw another water molecule. And because of this partial positive, this one also has a partial negative, they will create, let me draw it a little closer. Okay, they will create a hydrogen bond between the oxygen and hydrogen. And this is a hydrogen bond. Whenever you see a dash, or maybe you'll see dots connecting them, it's a bond that's formed because the partial positive and the partial negative of the oxygen and the hydrogen come together and they form a hydrogen bond. And water molecules will stack up with each other because of this, which makes water very elastic, makes water very use a high rate of it makes water's unique property. And I'm gonna probably have a video later about just on water molecules because of how cool and unique water is. But H2O, water molecule, is polar because of the electronegativity pull that the oxygen brings. It is grabbing the electrons at a greater tug than the hydrogens. you could think of the oxygen as a hog, because it's hogging the electrons, it's pulling them towards it. So any molecule where there's an uneven distribution of the pull, if one molecule is has greater electronegativity than the others, that is where it'll be a polar molecule. So let's go ahead and talk about nonpolar molecules. So nonpolar molecule I chose is CO2, carbon dioxide, and let's go ahead and give these guys the electrons that it's needed. There's that. So you have a carbon in the middle, double bonds to these two oxygens. What do we say? The oxygen is a hog of the electrons. So it is definitely pulling towards it's pulling the electrons towards it. But we have two oxygens on both sides. So if you think of a seesaw, would it be like that? You have two oxygens, carbon in the middle. No, because the oxygens are both equally attracted, equally pulling the electrons. They both have double bonds, so you have the same molecules. So it's it's an equal. They're going to be flat. Carbon right there. So you could kind of think of it as a seesaw example too. So whenever a molecule has even pooling of electrons, it'll be a nonpolar molecule. And this is very important to know what is polar and what's nonpolar, what is pooling, what's not pooling, and really electronegativity on a periodic table, it goes from right, top right. So you have oxygen up there, which is really electronegative. You have fluoride, which is a little bit electronegative. You have different molecules, chloride, that's electronegative. You have a couple of them that are more electronegative than most and are pooling. But important concept is that oxygens are hoggers of electrons. They pull at electrons. On this one over here, we have a slight pull to the carbon, but you have most of the pull coming from the oxygen. And this is equal, so it's a nonpolar. It has no polarity. And then what's a key sign to remember about polar? Key thing to look for is partials. So if you have a partial negative and a partial positive on your molecule, so partial positive, then you know it is going to be polar because there's an uneven distribution of electrons. The electrons are pulling, it's pulling towards the oxygen molecule, not the hydrogen, because the hydrogens are least electronegative. That's why hydrogens are very readily to give up their electrons. So we talked about covalent bonds. Let's talk about hydrogen bonds that are formed through the partial positive, partial negatives. And yeah, that's why water molecules are the way they are. I'm going to get a little bit more into that in another video. But this is pretty much the main gist of polar and nonpolar molecules. It's a general idea, but it's essential for you to know. And I would like to think of it more of a seesaw. So you have the carbon dioxide over here. I'll go ahead and erase this, and I'll try a little bigger. So you have a seesaw. This is the H2O one. So you have your oxygen right here and your H2 over here. So the oxygen is obviously more electronegativity, so it's going more that way. As far as the carbon dioxide, it's even. You have the carbon in the middle and the two oxygens pulling at equal weight, so they're the same. So nonpolar, polar. Polar is just when they're pulling more. So thank you guys for watching. I hope you guys enjoyed the video. Please leave questions, comments on the bottom if you guys need any additional help. My email's there. I'm gonna probably attach a document to help you guys get some problems, see what's polar, what's non-polar, and what you guys learn. So appreciate it. Thank you for watching. Please like and subscribe, and I'll see you guys next time. Adam the Science Tutor.